Ladies and gentlemen, boys and girls, welcome to another video. This video is for my 5th grade students and any student worldwide watching who is having difficulty with the concept of adding fractions with unlike denominators. DJ, drop a beat. Drop a beat one time for everybody who is tuning into this video that wants to get better at adding fractions with unlike denominators. Drop a beat one time, DJ. Thank you, DJ. All right, adding fractions with unlike denominators. Now, as you all know, we cannot add fractions with unlike denominators, not as they are. What we have to do, what the first step is you have to combine like terms. You have to change both of these fractions so they have the same denominator. Now, the easiest way to do that, the first step to doing that is to look at both denominators and determine the least common multiple among both the denominators. So the denominators in this problem are 4 and 3. So I'm going to be making multiples of 4, multiples of 3, and the least common multiple. Once I find the least common multiple of 4 and 3, that's what we can change the denominator to. So I'm going to make the multiples of 4, 8, 12, 16, 20, 24. So I just made a bunch of multiples of 4. Now I'm going to make some multiples of 3, 6, 9, 12, 15, 18, 21, kind of packed for space here. But if I want to go down to the next line, all right, 24. So we have a common multiple now. (24) is the least common multiple for 4 and 3. I've said this, as I've said before, in math, everything builds on the previous concept. So we spent a lot of time on missing addends and least common multiple because those are two skills that you need when it comes to adding fractions with unlike denominators. If you've mastered the skill of finding the least common multiple, it makes problems like this a lot easier. All right. So now the next step is we have to convert 3/4 to 20/4. So when I counted by 4s, if I'm counting by 4s, 4, 8, 12, 16, I got to figure out how many times did I have to count by 4 to get to 24. So I started with 4. I counted by 4 once. 8, I've counted by 4 twice. 12, I've counted by 4 3 times. 16, I've counted by 4 4 times. 20, I've counted by 4 5 times. 24, I've counted by 4 6 times. So if I multiply 4 times 6, I get 24. 4 times 6 equals 24. Let me going to get something to put this on over here. Hit that like button. Thank you so much for tuning in. I appreciate you. Please hit that like button. Thank you. All right, I'm about to move up the board now. All right. So 4 times 6 equals 24. What we do to the bottom, we got to do to the top. 3 times 6 equals 18. So if we were going to convert 3/4 to 24ths, 3/4 would be equal to 18 24ths. Now, converting 3 to 24ths. Skip counting by 3. 3, I've counted by 3 once. 6, I've counted by 3 twice. 9, I've counted by 3 3 times. 12, I've counted by 3 4 times. 15, I've counted by 3 5 times. 18, I've counted by 3 6 times. 21, I've counted by 3 7 times. 24, I've counted by 3 8 times. So 3 times 8 equals 24. Now, what we do to the bottom of the fraction, what we do to the denominator, we got to do the numerator. So now, I got to multiply 2 times 8. 2 times 8 equals 16. 3 times 8 equals 24. So 2/3 would be equal to 16 24ths. So now that we have a common denominator, now we can add the fractions. So when we add fractions and we have like terms, now that we have like terms, we simply add the numerators, and whatever the denominator is, we leave that the same. So the 24 we're going to leave the same. And then we have to add 18 plus 16. 18 plus 16 equals 34. So we have our answer, 34 24ths. Now the next step, we could leave that as is. I know some teachers that will allow you to leave the answer as is, where you don't have to simplify. I'm actually going to simplify. Going to change this to a mixed number. So 24 over 24 would be 1 whole. 24 24ths would be equal to 1 whole. Since 34 is 10 more than 24, 1 and 10 24ths would be the mixed number. I can simplify that further, though. Common multiple between 10, 20, and 24. But we don't even need to find a common multiple. There's a common factor of 10 and 24. 10 divided by 2 equals 5. 24 divided by 2 equals 12. So a way to simplify 10 24ths, that would be equal to 5 12ths. So 1 and 5 12ths would be our final answer. All right, now I am going to do another one. Let me know how you're doing with this comment, with this concept. Feel free to leave a comment. Let me do another one now. Yeah, I can definitely show you something on linear functions. I might not, that might be a few videos from now. I will definitely do that. No, write a problem in the comments and I will copy it down. Write a problem, write like an example of a linear function problem in the comments, and then I'll do like a future video on that problem. I might not be able to do that right away because I get why you're having a hard time with linear functions, because linear functions, they can be tricky. So I actually might need a day or two to study that before I do a video on it. But yeah, write a couple of linear function problems in the comments right now, and I'll copy them down. And then at some point, as soon as I can, I will do a future video on that. But yeah, put a linear function comment. Put a linear function problem in the comments. Kind of waiting for you to put a linear function problem in the comments. If you can't find one, that's okay. All right, perfect. Let me write that down. I'm actually going to take a picture of that comment with my phone. Hang on. I'm going to take a picture of that comment with my phone. All right, x to the third plus 3x 2 plus 6 times. Okay, I will do a future video on that for sure. All right, I'm going to do one more fractions with unlike denominators problem. Then, so here's what's on the agenda tonight. One more fraction with unlike denominators problem. After I do this next fraction with unlike denominators problem, I'm going to call it a video. 6x, not 6, all right. Okay, that's all right. One more fractions problem, then I'm going to call it a video. Then I'm going to do some research on this linear functions thing. And then hopefully before the end of the night, I can do another live video on linear functions. But one more fractions with unlike denominators problem before I call it a video. All right. All right, 5/10 plus 2/4. So again, first step, you got to convert these to like terms. So you got to find the common multiple, the least common multiple for 4 and 10. So I'm going to start counting by 4s. 4, 8, 12, 16. We make the first 4 numbers there. You know what? I'm going to add another line because we might need another line before we get to one. All right, so 10, 20, 30, 40. So we don't have a least common multiple yet, so we have to continue counting. So I'm going to count by 4s a few more times. I'm going to count by 10s a few more times. 20. Ooh, I think I see one. 20, 24, 50, 60, 70. I see a least common multiple. So 20 is a multiple of 10, and 20 is a multiple of 4. 20 is a multiple of 10, and 20 is a multiple of 4. So we have our least common multiple of 20. Now, to get 20, I had to count by 4 5 times. 4, 8, 12, 16, 20. I had to count by 4 5 times. So 4 times 5 equals 20. Now, whatever you do to the denominator, to convert it, you got to do the numerator. So 2 times 5. 2 times 5 equals 10. So 2/4 would be equal to 10/20. Now, counting by 10s, I had to count by 10s twice to get to 20. 10 times 2 equals 20. Five times 2 equals 10. So 5/10 would equal 10/20 also. Wow. So both of these problems are equal to 10/20. So 10/20 plus 10/20. So now to convert, we're going to leave the numerator the same. I mean, we're going to leave the denominator, not the numerator, not the numerator. The denominator, we are going to leave the denominator the same. And then we're going to add the numerator. So the denominator is going to stay the same, 20. 10 plus 10 equals 20. So our answer is 20/20ths. Or to simplify it, anytime the denominator and numerator are the same number, we have one whole. So our answer to this problem is 1. All right. So now I am going to conclude this video by saying thank you so much for liking. Thank you for commenting. I will be going on again. I will be going live again, hopefully before the end of the night. I'm going to do a little bit of research on how to solve executive functions. And then before the end of the night, hopefully within the next 20 to 30 minutes, I'll be able to go on and I'll be able to make another video. But thank you so much for tuning in and commenting, and hopefully I will see you soon.